This is part 2 of my DJI Tello drone videos. This one is going to be focusing on hand tracking using opencv, and this one is not going to use a horror cascade like the old one. Instead, this basically uses filtering techniques in video to isolate for hand movements. So I'll get more into it now. For this video, I'm trying out making a video of my programming process, a simplified version of what's going on while I'm coding, what I'm learning, and the way I'm iterating and problem solving. Similar to my last video, I'm using the DJI Tello drone that comes with the DJI Tello Pi API for Python. I'm using Python 3 opencv for the video processing, and I'm using Pygame to display a GUI for the program. For this project, you're going to need a webcam, and you're also going to need a DJI Tello drone. I basically found a cable to plug this into my computer, and I'm using this as a webcam because my monitors don't have a built-in webcam. I was making the last video, I noticed that the eye tracking wasn't working so well, so I uploaded that video, the shortened version, which basically doesn't really go in depth and kind of just talks about the eye tracking, because I was basically re-inspired to work on a second generation that works on hand tracking. So that's pretty much what inspired me to change it. And so you can see right here, the camera is on behind the tracking, and so I'm working on basically a gesture control system for my DJI Tello drone. In trying to isolate my hand from a scene, I'm going to have a lot of difficulty determining which is my hand and which is part of the background. Because my camera has no depth information and I'm just viewing from a webcam with a BGR or blue-green-red video feed from opencv, I'm going to be unable to determine the background noise and what is and isn't the hand. So to solve this problem and to account for the fact that there's different lightings, different lighting directions, different times of day, different skin colors, I'm going to have the user place their hand over a green box when it loads, when the program first loads, and my program is going to iterate through all the pixels in that small green box, which will be covered entirely by their palm. And this is going to basically take a sample of all the colors of their hand skin color, and it's going to take the lightest value and the darkest value in grayscale. With this 2D array of black and white pixels, or 0 and 1, I'm able to see a mask layer of everything that does apply to my filter and everything that doesn't apply to my filter. And using this, I can start to do contour detecting, which I'll talk about next, on my hand, which should be isolated from the background. I'm able to minimize the background noise by iterating over with a kernel, which looks at a certain number of pixels at a time, and if there's an odd pixel out, basically it gets rid of it. On the contrary, if there's a bunch of white pixels and it finds a black pixel in there, it turns it to white false negative, and that it actually is part of what we're supposed to be detecting. Using this, I'm able to make the mask more accurately depict what is the object we're trying to detect. And then once I have that, I'm able to run a opencv contour detector, which basically looks for big fluid shapes. And with that, it basically generates an area, but generates a bunch of attributes about the contours. And using that contour, I'm able to basically find the biggest shapes that have been masked off in the image, which in our case, hopefully is the hand. What I'm adding here is something that grabs all the contours that you're seeing in green. It iterates through the contours through a pre-made function and finds the biggest contour in terms of area from the image. Using that contour, it basically creates a bounding box around it, and this is what I'm using as the best prediction for where the hand is. So this blue box you can see is where its best guess at what the hand currently is based on all the parameters I've put in. One problem I've had while trying to smooth out the detection of a hand in a frame is the fact that hands tend to, because of the masking I do and the different color differentiation, it seems like the hand will disappear and then it'll start picking up on my arm. And I don't want the drone to go flying off in one direction because it finds my arm to be my hand instead of my hand because it is at a bad angle. So I'm trying to improve a bias in the program that makes the program want to predict a hand that's similar to the one it just predicted. So to do this, I created a hand class that is a getLocation function and a width and a height. So then what happens is after I found all the contours, then what I do is I've created a self.hand object that is the one hand that's in the middle of tracking. If a hand doesn't yet exist, it just takes the biggest contour and presumes that's the hand, because I'm presuming at first the biggest object it sees is your hand, nice and up front like that. After that point, if there is a hand that exists, it gets the hands, it sorts them by size in terms of area, and then iterates through them. The first thing I do is get the X and Y and the width and height, the height of that contour, and I get the X and Y width and height of the current hand, which is basically the last predicted hand for the previous frame. Then, my first step, as I say here, I compute how close the new contour is from the last hand location. In this case, I use a distance function to calculate how far the 2 points are. Then I calculate the difference in the width and the difference in the height. And then once I add these three together, I calculate a score, and I set the lowest score to be the new best hand prediction. And after iterating through all of them, it's going to end up with the hand that it's found, the contour with the lowest score, which by the one that has the least big distance from the last hand and the least difference between the size of the hands. So this should keep all of the predictions quite similar. I then set the current hand to be the best performing hand of all the contours found before. Then I grab the X, Y width and height of that hand, and then I put a rectangle around that point. And as you can see right now, it is tending to want to stay to my hand. So right now it's working, but what I've noticed is it can get caught on other objects. Like it gets caught on something small and doesn't want to go back to something big. For example, look, now it's stuck on my neck and it doesn't want my hand because my hand's too big. It wants to stay to something small like that. And I'm not sure how to fix that yet, but it does seem like once it does lock onto my hand, and I can kind of grow it to be a bigger size, but I almost have to get lucky. See, it's tending to want to get something small, like it wants to get something small because it's minimizing that number. The smaller objects seem to minimize that number, so I'm figuring out a way around that. So this is going to conclude the first part about hand tracking with opencv and Python. I decided to conclude it here just because things were starting to take a long time. I was getting busy doing other things, and there's still a lot of work that needs to be done. Just a few issues I'm having with locking onto the hand and actually finding that hand. Some of the things I smoothed out in the video helped a lot, but I still have a lot of progress to make, and there's a bunch of other projects I'm excited about and working on right now that I also want to make videos for. So I figured if I put this one out there, I can come back to it, keep working on it. I still have the code up and running, and the gesture recognition I still have to do. But for now, I think this is going to conclude this section, so thanks for watching, and I'll see you later.